All right, in this video, I'm just going to take you through some practice equations on how to balance these. I've got 3 different equations I'm going to walk you through. So the first one is another example of an equation that starts out in words, so you need to convert it first into an equation. So this time we've got propane instead of methane, combines with oxygen when burning to yield carbon dioxide and water vapor. So the first thing we need to do is convert this into our chemical equation. So we know that there's going to be an arrow. An arrow is going to indicate production. Another word for that is yield. So this means produce or yield. So over on this side of the equation, we're going to go with C3H8. And whenever I write out my equations, I make sure I have room in front to be able to write any coefficients in. And I always do this with a pencil if I'm not doing it on the computer, just so that I can erase anything if I put in the wrong coefficients. All right, so we know we've got propane, we're given that one. We know oxygen comes as O2, so we've got oxygen gas. And we're going to make carbon dioxide. So we know that one is, I'm going to erase that. I put that too close. Grab my pen again. Give myself space this time. So CO2. And we also make our water vapor. So we're going to make water. Okay, so first thing to do, just like before, is inventory what we have on each side. So we know we have carbons, hydrogens, and oxygens on both sides. So we just need to total them up. So we know over here we have 3 carbon, we have 8 hydrogen, and we have 2 oxygen. And on this side, 1 carbon, we've got 2 hydrogen, and we have 3 oxygen, because we've got 2 in the carbon dioxide and 1 in the water. So pick whatever one you want to balance first. I'm going to go with the hydrogen, just because it's the one we have the most of. You can pick whichever one you want to go first. It's up to you. But I'm going to pick hydrogen. So H8. So we've got 8 here. So to make 8 on this side, put a 4 in front of the hydrogen. So that, remember, anything you put here, you multiply across whatever's in here. So 4 times 2 is going to give us our 8. That's also going to change the number of oxygens. So we now have 2 here. We have 4 here. So that's going to give us 6. All right. So that fixed our hydrogen. Let's take a look at carbon. So can we fix carbon by putting a coefficient somewhere? Yeah, we can. Because we've got 3 carbon on this side, 1 carbon on that side. That's a pretty easy fix. We put a 3 here. So we've got 3 on this side. We now have 3 on that side. So we're getting a little closer, but since we put a coefficient here, that changes the number of oxygens again. So we got to cross that out. So now we have 3 times 2, so 6 plus 4. So that gives us 10. So we've got the same number of carbons, same number of hydrogens. Now we just need to balance the oxygens. So that means we've got more on this side. We have 10. So we need to do something to this one right here in order to balance it to get our number of 10. So we're going to put a 5 in front of this oxygen. 5 times 2 is going to give us our 10. All right. So the balanced equation here, remember this would be an assumed 1. So 1 propane plus 5 oxygen molecules is going to yield 3 carbon dioxides and 4 water molecules. All right, let's try another one. Now this equation looks crazy, but it's not as bad as it seems, okay? Because these guys right here in the parentheses, they act as as molecules. I know you've got individual elements, but this guy acts as a unit. So CO3 acts as a whole unit. CO3 here, HCO3 acts as a unit. Okay, CO3 is carbonate. So these guys count as one. So when you're writing up your list, so we've got calcium, we have HCO3, so you actually do it as HCO3. So that's one whole thing. So you count this basically as an atom. And then you've got sodium, and then you've got CO3. And as one atom. Okay. So write this guy out over here. So we've got calcium. We've got, this is bicarbonate, if you're wondering what the HCO3 stands for. And then sodium. So we have them in the same order. CO3. All right. So this side, pretty easy. One of everybody. All right. Because there aren't any subscripts, there aren't any coefficients. This side, we do have some subscripts. This subscript only applies to this guy in the parentheses. So we have 1 calcium, we have 2 of this HCO3, we have 2 sodium, and 1 of the carbonate. So what is not in balance, what is not equal on both sides? So it is these two right here, right? So the HCO3 and the sodium, we'll look at that. They are together. So if we put a 2 here, we've got now 2 sodium and 2 bicarbonate, and now we're equal. So in this one, it just took a 2 right here because that 2 still multiplies just like normal. So 2 sodium, 2 of these guys in the parentheses, and we are good to go. All right, one more. So here we're making ammonia. We're making ammonia out of hydrogen and nitrogen gas. So I'm actually going to rewrite this formula so I have space to put in the coefficients, because as you saw on that previous one, I didn't have space to write in the coefficients, and we might need some more here, because as you can see, the numbers are a little different. All right, so the list for the atoms is pretty short. It's H and N, and keep them in the same order, H and N. So on this side, we have 2 of each, and on this side, we have 3 of this one and 1 of that one. So what can we do? Well, the easiest thing here is actually to put a number on this one. Since this is the only compound on this side, if we put a coefficient here, it's easier to adjust any of the coefficients on that side. So let's see what happens if we put a 2 on the nitrogen, because we have 2 on that side. So that does a change this one to a 2. And that makes hydrogen 2 times 3, so that's going to make the hydrogen 6. So that does balance the nitrogens. And now we've got 6 hydrogens. So we have to do something to the hydrogens on this side. So if we put a 3 in front of the hydrogen, 3 times 2 gets us the 6 on the other side. So that's just walking you through some of the balancing of equations. For our course, we only would be balancing these kinds of fairly simple equations. We wouldn't get into the more complex ones.